Hello Year 10 Triple Science students. It is time for lesson 5 of this topic and we are back to our usual pattern of the lesson today. So here's a quick starter for each one. Say if it is a group 1 metal or a transition metal. You don't have to write it down, just think it to yourself. Quiz your memory, pause it now. Here come the answers. Number 1, transition metals in the central block. Number 2, group 1 gets more reactive down the group. Number 3, transition metals have high density, high conductivity. Number 4, group 1, lower density than most metals. Number 5, transition metals make good catalysts. Number 6, group 1 always has a 1+ charge on its ions. Number 7, transition metals use Roman numerals in the names if it's a positive ion in a salt. Transition metals also form a range of coloured salts for number 8. Number 9, it's alkali metals that react with water to produce hydroxide and hydrogen gas. And both of them will react with chlorine to form a chloride salt. Today's driving question is, are nanoparticles useful or dangerous? Right, have a quick look at this. Stain repellent shirts. The stain just doesn't even touch the fabric. It just rolls straight off. How does it work? Well, stain repellent shirts tend to be coated with nanoparticles. Now, nanoparticles are very tiny particles, around 1 × 10⁻⁹ meters. And there are new uses, new applications that are making use of our discovery of nanoparticles. So stain repellent fabrics is one example, along with scratch-proof glasses, crack-resistant paints, anti-graffitiing coatings for walls, plasters that kill bacteria. These new applications all make use of nanoparticles, particles which are 1 × 10⁻⁹ meters in size. And potentially we could have even more inventions in the future. For example, carbon nanotubes could be strong enough to form a chain reaching up to a space station. At the moment, they can't be made to be long enough, but they are certainly strong enough. Carbon nanotubes look like this. These hexagons are actually made of 6 carbon atoms bonded in a ring, and it forms a tube-like structure. And the tube-like structure is on the scale of 1 × 10⁻⁹ meters. Okay, so 1 × 10⁻⁹ meter is referred to as 1 nanometer. So nano means 1 × 10⁻⁹. You may have come across carbon nanotubes and indeed fullerenes in the first structure and bonding topic because they are counted as giant covalent structures. They're made of carbon atoms with covalent bonds in between. Now, you might think it's a bit weird to call it a giant covalent structure when it's only 1 × 10⁻⁹ meters long, but it's not counted as a covalent molecule structure because molecules have 2 or 3 atoms in them, like H2O or CO2. We can have larger molecules like polymers and also proteins, but there's enough atoms in a carbon nanotube to make it counted as a giant covalent structure. Sometimes they're called macromolecules, but really they count as giant covalent structures, even though they are 1 × 10⁻⁹ meters. Now, not all nanoparticles are made of carbon, so they're not all giant covalent structures. I just mentioned this as revision of structure and bonding topic 1, that these particular nanoparticles are also counted as giant covalent structures. There are many potential uses for a wide range of nanoparticles because they often have unusual properties, and those unusual properties come from their small size. For example, carbon nanotubes are immensely strong, and the nanoparticles in these self-cleaning fabrics are repellent to water, so the water just repels instead of touching the actual fabric. And those unusual properties come from their particularly large surface area, and their large surface area is caused by their very small size. And if you think back to rates of reaction, if you have lots of small particles, there's lots of surface area. Whereas if you have a small number of large particles, most of the atoms are on the middle, less are on the surface. We call that a smaller surface area. So to get a large surface area, you need lots of small particles so that most of the atoms are on the outside and not stuck in the middle of the particle. So nanoparticles have that feature. They're so small, a lot of the atoms are on the outside, not so many in the middle. We say it has a large surface area because of its small size. Okay, pause the video to think of 3 facts about nanoparticles. What can you remember of what I've explained so far? Pause it now. Here we go. What was my list? 1 times 10 to the minus 9 meters in size. Sometimes that is called 1 nanometer. Nano refers to 1 times 10 to the minus 9. 1 nanometer, or 1 times 10 to the minus 9 meters inside. They have unusual properties caused by their large surface area, and examples include carbon nanotubes or fullerenes. We are going to look at some more examples. Sometimes I get classes to do some research on this. There is a bite-sized link which contains quite a lot of information about them. But in this video, I'm going to take you through that information. Then we're going to do our usual writing task with orange, green, yellow, and blue. Now, some keywords: bulk and nano. The same chemical can have different properties in bulk and nano form. Now, by bulk form, what we mean is the usual everyday form that we can use, that's on our human scale, that we can see and touch. Here is zinc oxide. So it's just a normal sort of powder, white powder. By its nano form, we mean those tiny nano-sized particles, 1 times 10 to the minus 9. Now, in its bulk form, zinc oxide is a white powder, but in its nanoparticle form, it's transparent and it's see-through. It's a bit like a snowflake, it's like a tiny crystal, but on the scale of 1 times 10 to the minus 9 meters. So the same chemical can have different properties in bulk form, which is the ordinary everyday form, and nano form when it is made into a nanoparticle on a scale of 1 times 10 to the minus 9 meters. Now, because zinc oxide is transparent in its nano form, and it also blocks ultraviolet light, it can be used in sunscreen. And unlike most sunscreens, it's not white, it's see-through, so it doesn't leave white marks on your skin. You don't have to rub it in so much, you can't see it. So some people prefer this because they like the fact that it doesn't form white marks. However, there is a risk. If you are applying sunscreen but you can't see where you're putting it, you can't quite tell if you've covered all your skin. And therefore you might apply it in a patchy way, and that would leave parts of your skin vulnerable to the UV radiation, which, as you probably are aware, can cause skin cancer or skin issues. So, benefits and drawbacks of zinc oxide nanoparticles. It blocks ultraviolet light, so it makes a good sunscreen, and in the form of nanoparticles, it's transparent. But there's a risk there that it could be difficult to make sure you've applied it evenly and fully covered the skin. Okay, right, here's another example. Silver nanoparticles. Right, now, we can actually watch all this. I'll show this in the classroom. This is just a guy talking about it. I think we'll just skip this for now and I'll tell you what it is, right? Silver nanoparticles are used in antibacterial plasters. Now, if you see plasters like this where it says silver, the silver is actually, it works most effectively if it's been made in the form of nanoparticles. Now, depending on which brand you buy, they might have made it into nanoparticles properly and it will be effective. Or if they haven't made it into nanoparticles properly, it will still have some effect, but it will be less effective. Nanoparticulate silver, so that means silver nanoparticles, has antibacterial properties. So it will kill bacteria and stop the bacteria from infecting the wound. However, it never loses its antibacterial property. And what sometimes happens is if people chuck these plasters away after use, if they get into the environment, it can sometimes kill useful bacteria, for example, bacteria that help things to decompose in the soil, as well as harmful bacteria. So it's important to try and make sure that we dispose of them carefully, because if it gets into the environment, it can continue to kill bacteria, which is useful. So again, benefits and drawbacks to silver nanoparticles. Right, self-cleaning windows. Here's another use of nanoparticles. This is this is an advert for a window company where they've invented some windows which clean themselves. Now, it's a mixture actually of, there's a nanoparticle coating on the window. And when the light shines on that coating, it activates the coating and it starts to break down organic matter. So dirt, anything soil, anything living will be broken down by the nanoparticle coating. Then, when you apply water to it, it all washes away much more easily. So it's the combination of light from the sun activates the nanoparticles and starts the process of breaking down organic matter, and water helps to sort of regenerate the nanoparticle coating so it will continue to work even after it's been used the first time. So it's like a self-regenerating system. When you clean it with water, it helps to rejuvenate the nanoparticles, put them back to their original condition so they can continue to work the next time. Right, so nanoparticulate coatings. So coating applied to glass to help it kind of clean itself. It requires sunlight to activate the nanoparticles. It requires water, so it could be rainwater, to keep refreshing the nanoparticles. And really, the nanoparticles are acting as a catalyst. It's speeding up the breakdown process for the organic matter, the dirt, that gets onto windows. Now, there is a drawback. If we were to get that nanoparticle coating onto our skin, if we transferred it into our mouth and inside our body, it could catalyze reactions inside the body that would not normally happen. And that could be harmful to our bodies. Right? So it could potentially be harmful. If it gets inside our body, it will still continue to act as a catalyst, and that could produce some harmful reactions inside our body. So again, benefits and drawbacks. Just to clarify, the word particulate means made of particles. So if it's nanoparticulate, it is made of nanoparticles, 1 times 10 to the minus 9 in meters. Okay, memory test. 3 uses of nanoparticles. Can you think of what is useful about it and what the potential dangers are? You don't have to write this down. It's going to be part of the written task in a little while. So just think it. Check your memory. Can you remember all 6 points? Pause it now. I'm going to move this onto the answers. I hope you've had a good think about that. If there's somebody else in the room, I hope you've discussed it with them. Right, silver, used for antibacterial plasters. It's the antibacterial properties that are important, but it can continue to kill useful soil bacteria after it's been thrown away. Zinc oxide makes for a transparent sunscreen. It's transparent, which is a useful property, but it may be applied to skin incompletely, which leaves a risk of skin cancer from ultraviolet rays. Particulate coatings. Self-cleaning windows. Its property is it helps to break down dirt. But the danger is it could catalyze reactions inside the body, producing harmful substances. Right, now, in the written task, you are going to need to evaluate those reasons for and against. So what do we mean by evaluate? Well, a thinking skills evaluation is different to when we evaluate a practical or investigation. So I'm just going to explain to you what I mean by that. A thinking skills evaluation will compare the importance of each good or bad point. Now, you could get, 5 points for and only 2 points against. But you might decide that the reasons against are so important, they outweigh the reasons for. So you have to decide for each reason for or against, how important is this and which side outweighs the other one. So an evaluation will compare how the size or importance of the reasons for and against compare to each other. So here's an example. Antibacterial plasters, should we use them? Well, the reasons for, they're antibacterial, so they can stop wounds being infected by bacteria, but the reasons against, it could kill useful soil bacteria after being thrown away. So in my evaluation, I have to weigh out which is more or less important. So I've written this as if I was a student. So overall, I think we should use antibacterial plasters, as it is common to get cuts and scrapes. So there's a large risk of infection happening. So I think the health benefit of avoiding infection outweighs the risk of killing bacteria in the soil, because human health is more important, in my opinion. That's quite a large risk. And most people put the plaster in the bin anyway, so the risk of it killing bacteria in the soil is fairly low. Also, the risk to bacteria in the soil can be further minimized if people dispose of the plasters carefully. So if they made it clear on the packet, people would throw them in the bin, and then that reason against would be even smaller. So basically, I'm trying to say that I think the reasons for strongly outweigh the reasons against in this case. Right, before we move on to the writing task, quick check. What is a nanoparticle? Pause the video. Is it A, B, C, or D? Pause it now. And the correct answer was A. A particle around 1 times 10 to the minus 9 in size with unusual properties caused by its large surface area. Remember, a tiny particle will have a larger surface area. Right, time for the writing task of this lesson. So describing some uses, explaining why nanoparticles are unusual, but then summarizing the uses and dangers, or the benefits and drawbacks, and then evaluating which side outweighs the other one. Okay, now I would suggest you use these sentence starters. Okay, you can, when you get onto using your understanding and evaluating it, you can summarize it in a table. You can write in bullet points. How you lay it out is up to you. But pause the video now. Take as long as you need to use these sentence starters to get the main basic facts down, but then try and get some good detail into your writing for summarizing the benefits and drawbacks, uses and dangers, and then trying to evaluate them, weigh them up Do the uses outweigh the dangers, or do the dangers outweigh the uses? Pause the video for as long as you need. Go for it, Year 10. I'm going to move this on to the answers now. Now, remember to tick things if you get them right, and hopefully feel proud about that. But remember, you can also write things in if you didn't think of it. Okay, uses of nanoparticles. So, transparent sunscreen, self-cleaning windows, antibacterial plasters, carbon nanotubes, stain repellent fabric. I've put a sixth one in there as well, scratch-proof glasses. And they are useful compared to normal particles because they have a tiny size. I use the word bulk here. They have a tiny size compared to the same chemical in bulk form. They have unusual properties compared to the bulk form because they have a large surface area caused by their small size. This idea here of surface area to volume ratio, that's going to be in next lesson. I should have changed that for this, so just ignore that. It's a large surface area caused by its small size. Right, what have we got on this slide? Zinc oxide, uses, blocks ultraviolet light, used in sunscreens, transparent. Danger, more difficult to tell where it's been applied. Now, I've put my evaluation in straight away. I would be concerned about the danger as UV radiation can cause skin cancer. I think the danger outweighs the use, as there are other sunscreens available which are easier to apply to the body more thoroughly. So I'm thinking, actually, I might choose to buy one which is not transparent because I want to make sure I'm not leaving myself at danger of UV radiation. Silver nanoparticles. I did this in the example earlier. Antibacterial, so it will stop wounds getting infected with bacteria, but it can continue to kill bacteria after they've been thrown away. So, for example, useful bacteria, maybe in the soil, decomposes. I believe the uses outweigh the dangers. High risk of infection from wounds with bacteria. Silver nanoparticles help people stay safe. Only a small effect on the environment, especially if we dispose of the dressings carefully. Right, nano-particulate window dressing, used as a catalyst, speeds up the breakdown of dirt. It needs sunlight and water to help it work. It makes a good catalyst. Again, we're going to do more on surface area to volume ratio next lesson. So today we're just calling it large surface area. Helps to be a good catalyst, but if it gets inside the body, it could catalyze reactions. Right, now, I've said, from what I've heard so far, I believe the dangers outweigh the risks. It sounds like it would be quite easy for someone to get nanoparticles on their skin from touching the windows. Now, I don't know if that's really true. It depends how... I'm sure the companies who make this have done lots and lots of safety tests. So I could research that, and I could find out that it's probably more safe than I realise. But just based on what I've heard today, actually, do I want to run the risk of getting those nanoparticles on my hands if I'm opening and closing the windows? I'm sure I'm just exaggerating the risks here. The companies will have done lots of risk assessments, lots of tests to make them safe. I just haven't found out about it yet. So I should really go and research that. Okay. Right, today I have achieved describe, because I can describe 5 uses of nanoparticles. I can explain why nanoparticles are useful compared to normal particles or bulk particles. Today I achieved use, or I should say analyze here, summarizing the uses and dangers, pros and cons, benefits, drawbacks. We normally call that analyze. Then evaluate is weighing up whether the uses outweigh the dangers. So what have you achieved today? Okay, please remember to go back to show my homework, click on the show my homework entry of this lesson and complete the 10-question quiz. Now, next lesson, we are going to go into surface area to volume ratio, which is something you may well have come across in biology, and we need to apply that to nanoparticles in order to help us calculate their surface area to volume ratio. Let's see how that affects their properties. Okay, thank you for today's work. Well done. Let's keep the effort going. Well done, Year 10. Thank you very much.